In this former AP test question, we're asked to first determine if the function is continuous for all x when a is 2 and b is 3. So the first thing that we'll want to look at is the left-hand piece of the function, the absolute value of x minus 1 plus 2. That piece is continuous for all real numbers. And the other piece, which is ax squared plus bx, or when a is 2, 2x squared, and when b is 3, plus 3x, and that's also continuous for all real numbers. So the only question we then have is this continuous at the point where the two different functions hit each other, which is at x equals 1. So we want to know if this equals the same thing at x equals 1. Effectively, what we're trying to find out is the limit as x approaches 1 from the left of f of x equal to the limit as x approaches 1 from the right of f of x. So, if we plug in 1 to both of these, on the left-hand side we end up with 2, and on the right-hand side we end up with 2 plus 3. Clearly, those are not equal to each other, and the answer to the first part of the question is no. The reason being the limit from the left is not equal to the limit from the right. And part of the definition of continuity is that the limit as x approaches our c value, or 1, needs to exist. And it does not, because the left and the right-hand limits are different. Now, the next thing we need to do is figure out all values for which of a and b for which f is a continuous function. So that means we need to figure out at x equals 1, so on the left-hand side, when we have 2, and on the right-hand side, when x equals 1, we have a plus b. So if x equals 1, the left is 2, and the right limit is a plus b. So all we're looking for is all of the values that satisfy this equation, and that's the answer to the second part of it. In this question, we're looking for the limits as x approaches infinity and negative infinity of the function x squared minus 2x minus 1 times the quantity e to the x. So if we look at x approaching infinity, the part in the parentheses, x squared minus 2x minus 1, is infinity. And the part outside the parentheses is e to the infinity, which is also infinity. And since you have an infinity times another infinity, that's going to keep getting larger, and we can say that this limit is infinity, or we might say it doesn't exist because a limit technically has to be a finite number, but either infinity or does not exist would be an acceptable answer on the AP test. For the limit as x approaches negative infinity, when we plug negative infinity into the part in the parentheses and we square it, we end up with negative infinity squared is just a positive, very large number. The rest of it is sort of insignificant in terms of the squared infinity being much larger than the just regular infinity. And then we have e to the negative infinity. Well, e to the negative infinity drops to the denominator and becomes an infinity over e to the infinity. And this denominator is increasing more rapidly than the numerator. Therefore, this is trending towards 0. So the limit as x approaches negative infinity is 0.